All right, so second part of this video, I just ran out of time before. And now we're graphing y equals the cosine of x divided by 2. So again, this is a horizontal dilation because the x is being multiplied by a constant. By what factor? So every xy on the original cosine x graph will get transformed by x divided by 1/2. So what are we really doing there? We're really saying multiply every x value by 2. So it's a horizontal dilation by a factor of 2. So it's always what are you multiplying? The factor of the dilation factor, whether it's vertical or horizontal, is always what are you multiplying the x value by or the y value by. Okay, so think about the original cosine graph. So the original cosine graph between 0 and 2 pi, we had one period. So let's divvy this up. These are the original places where we had points on the cosine graph. It started at 1, and then it hit 0, and then it hit -1, 0, 1. Here's the original. All right, so when I take the x value 0 and I multiply it by 2, I'm still at 0, 1. But when I take x over 2, or sorry, pi over 2, and multiply it by 2, I get pi. So instead of 0 pi over 2, I'm at 0 pi. And at pi, you're going to be really at 2 pi. So instead of pi -1, 2 pi -1. So this is just this half of this curve, right? Now, what about the rest of it? Well, if we kept going with this, we could extend this on. So let's see. The next period would be 4 pi, 3 pi. Put these marks in. So boop, 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 boop. All right. So the next period, like at 2 pi, or sorry, where's our next point? 3 pi over 2. We should really be at about, multiply that by 2. We should be at 3 pi on the axis. So let's just estimate where that is. So the next point that hits 0 is like about here. And then at 2 pi, the final point, instead of 2 pi 1, that would be at 4 pi 1. So my scale is off a little bit, but we have that. So this is a horizontal stretch because we're doubling every x value. And we can copy those same points to the other side and just kind of go from here. I'm not going to be able to fit a full period on, but this is one period and like a half. All right, let's graph y equals 2 sine x, and then we'll talk about domain and range. So what does a 2 out in front of a function do? 2 times f of x. That takes every x, y value, and it multiplies the y value by 2. So back to the original sine graph. That looks like this. Remember, you should get pretty used to drawing this original shape. 0, 0 will still be 0, 0. Pi over 2 is the next point. Instead of pi over 2, 1, it's going to be pi over 2, 2. At pi, we hit 0. At 3 pi over 2, we hit -2. And at 2 pi, we hit 0 again. So it's just a taller, it's a vertically stretched graph by a factor of 2. And you can do the same thing in the negative direction. All right, so let's talk about domain and range. For the sine function, there are no vertical asymptotes, there are no holes in the graph or jumps, so all real numbers for our domain. But the range is locked in, even though we have arrows on either side. Remember, we have a global max and a global min, so the lowest value on the sine graph, on this sine graph, is -2, and the highest value is 2. The original domain and range is -1, or the original range is -1 to 1. This one got doubled because of the amplitude. All right, so -3 cosine x. So this is going to take all of the original xy coordinates and multiply the y values by -3. So this should be an x-axis reflection and a vertical stretch. The original cosine graph starts at 1, 0, -1, 0, 1. So at 0, instead of starting at 1, we're going to multiply that by -3. So I guess I'm off the graph a bit. At pi over 2, we're hitting 0. 0 times negative 3 is still 0. At pi, we're normally at negative 1. So at pi, we're going to be at 3. Let's just estimate that to be up here. And then at 3 pi over 2, back to 0. At 2 pi, negative 3. So this is a vertically stretched graph. Arrows are a little messy here. And if I wanted to go to the other side, I could. Just continue the pattern. These are periodic functions, which means they have the same pattern over and over across the same set of x values. All right, so what about some rules? These are stretching and shrinking rules and dilation rules, but there's some rules that some terminology that we have for sine and cosine graphs. So far, we've looked at what if you have a multiplier out in front of your sine or cosine function, and what if you have a multiplier inside of the sine or cosine function. So the A value is called the amplitude. The amplitude value is the absolute value of A. So the amplitude in number 5 was 2, and the amplitude in number 6 was 3, even though it says negative 3. And this is the distance between the extreme values, meaning max or min, and the midline. What's the midline? The midline is in our case, it's like the x-axis. Or if we start shifting these up and down, it will be the distance between like where the center of the graph was. So for any sine function, the midline is, that was rough. Midline is this line that's supposed to be horizontal that goes through this. And for a cosine graph, the midline is, again, the x-axis, but if we shift it up, it's the point that goes through all of these middle points. All right, find the domain, range, and period for each function. Oh, sorry, period. So the period we figured out by stretching and shrinking, but there's also a formula for the period. The formula is 2 pi, full circle, divided by b. Think about this. The original period of a sine and cosine graph is 2 pi. And if we have a stretch or a shrink inside of the x, if we divide 2 pi by that stretch or shrink, it's either going to stretch out the 2 pi or it will shrink it, depending on what the value of b is. So if we take a look at these rules, find the domain, range, and period for each function. So let's start with the period. So the period here is 2 pi divided by 4, which is pi over 2. So this means the entire cosine graph is going to be skinny because it's going to fit within pi over 2 units. The whole thing will fit in here. That's because a dilation factor of 4 or of 1/4 is going to be a horizontal shrink. What about domain and range? Well, for sine and cosine, remember, domain is always all real numbers. There are no vertical asymptotes. There are no jumps, gaps, holes, anything in a sine or cosine graph. The range depends on the amplitude. So the amplitude is 5. That means that this cosine graph will go up to 5 and down to negative 5. So our range is negative 5 to 5. For number 8, the period is 2 pi divided by, b is 1/3. So 2 pi divided by 1/3 is really like 2 pi times 3. So that's 6 pi. So now this sine curve, instead of being normal like this, it's going to get stretched way out. So it stretches across 6 pi. The domain is still all real numbers. The range is not dependent on the period. It's dependent on the amplitude. So this graph only goes up to 1/2 and down to negative 1/2. All right, what about y equals negative cosine of x plus pi? So the period is 2 pi divided by b. Now, b here is equal to 1. This is not b. We will talk about what this plus pi is or how to address it when we're graphing later, but this is a horizontal shift if you're adding or subtracting something inside of a function. So this is going to be left pi, but we won't worry about that yet. So when we say 2 pi divided by b, it's still 2 pi divided by 1. So this has the regular period of 2 pi, It has been shifted horizontally, but we're not answering that question. Domain is still all real numbers. And then what about the range? So horizontal shift does not affect the range. Let's just make note that it's a horizontal shift. The negative in front of the cosine just means that there's been an x-axis reflection. It looks like that. But it's still that the low point is -1 and the high point is +1. For this one, the period is 2 pi divided by pi over 2. That's 2 pi times 2 over pi. So the pi's cancel. So the period is 4, as in 4 radians, as in more than pi, more than pi, less than, remember 3 pi over 2 was like 4.71, I think. So 4 radians is like, if we were graphing that, this graph would stretch not quite to 2 pi. It would complete a cycle between pi and 3 pi over 2. The domain is still all real numbers, and the range is just about the amplitude, which is 2. So this graph goes from -2 to +2. For this one, the period is 2 pi divided by 2, which is pi. So that's a horizontal shrink. This graph is skinnier because it completes the cosine curve between 0 and pi. The amplitude is 3, so the domain is all reals. The range is affected by the 3, so this graph will stretch from -3 to +3. And then our last one has sine x plus 10. So this is like f of x plus 10. So this is a vertical shift up 10. We have some of these in our graphing homework tonight. So if we were to graph this thing, instead of the midline for the sine graph being on the x-axis, I like to draw the midline like this. This is where the middle of the graph is going to be. This would be at y equals 10. And then normally our sine graph starts at 0, right, and goes up like this, something like this. So instead of the graph starting at 0, the new midline is at 10. And then it goes up to 1, so up 1 unit to 11, back to the midline. This point that was at -1, so you're 1 unit below your midline, so that's 9. And then back up here. So this is what that graph would look like. And we've got some practice on our homework tonight of that. So what is the domain and range? So, all right, let's start with that. Domain is still all reals. Range, so it's not just -1 to 1. Now that you've shifted up 10, your lowest point is 9 and your highest point is 11. And then what about the period? Well, there's nothing in front of the x, so b is equal to 1. So 2 pi divided by 1 is 2 pi. So we're going to practice graphing these. Sometimes you're asked to find domain and range. Sometimes you're finding period and amplitude. But if you have a vertical shift, move the midline, which would be the x-axis, draw that in. That's what I like to do. And then use that as like your new x-axis. All right, come see me if you have questions on this.